Okay guys, just a very quick short update before I continue working on the chassis of the Westinghouse H-598P4. I think I found the reason why the radio was probably discarded. And the reason is this. If you look at the schematic, and I'll try to zoom in so that you can see it. So if you look at the schematic, you'll notice the rectifier, which is the selenium rectifier, which is this little thing here. This is the selenium rectifier, right? So the selenium rectifier, represented by this symbol here, comes from the AC plug and runs through a 150 ohm flexible resistor, which is this here. Once I'll unmount the selenium rectifier, I'll show you well, you can see a small part of it. So this is a flexible resistor or flexi resistor. It's rated at 150 ohms. I measured it. It measures okay. Now, the problem is this. The selenium rectifier doesn't measure out. I mean by that, if I measure conductivity of the selenium rectifier, it doesn't conduct neither in one direction or in the other. In other words, it's an open conductor. So there's no conductivity through that. So I looked on the schematic, and then I noticed that there is an electrolytic capacitor right here where my finger is pointing of 60 microfarad. Now, I also measured, just to be on the safe side, the CAN dome, which turns out to be a 2000 ohm resistor, and another power resistor of 820 ohms, which measured out as I believe 850, but is still within tolerance. Okay, so remember I told you last time that there seemed to be a little bit of burning on the connector. As you can see, there's a little bit of blackish goo on one of the contacts of the connector. So I believe I found out the reason, and it's actually quite simple. This electrolytic of 60 microfarad at a certain point must have shorted out, meaning that all the power coming from the AC socket went through the selenium rectifier and then through a small resistance of a 5-watt resistance of 150 ohms and straight to the ground. In other words, this was a dead short. So the selenium rectifier is not that rugged a part, which means that probably the short took out the selenium rectifier. In other words, the selenium rectifier burned through because of a short in the 60 microfarad electrolytic capacitor. And I believe that is the reason why this radio eventually was discarded or thrown away. And in my opinion, although the selenium rectifier doesn't look burned, when it shorted out, it must have smelled pretty horrid. So that too might have been a reason why eventually the owner of the radio discarded the radio. So what I'm going to do is I'm going to unmount the selenium rectifier, and I'm going to replace it by a 1N4007, I believe, a diode, a regular diode. Or maybe I'll leave it in, but I'll disconnect it because it's dead anyway. And as you remember, I took out the electrolytic, I gutted the original electrolytic, and I ordered the right parts to stuff it again. So I ordered, I believe, a 57 microfarad to replace the 60 microfarad, which is close enough and within tolerance, 10% tolerance. So I believe that will work just fine. The resistors, fortunately, this 5 watt one, and this 2000 ohms 10 watt canned ohm resistor, fortunately resisted the short, and specifically this 150 ohm, fortunately, wasn't burned through. So in effect, what happened was that at a certain point the electrolytic shorted, and there was a sudden rush of current going through the connector all the way through the diode and to ground. And as you can see, it's a hot chassis, meaning that the other pin of the AC goes straight to the chassis. So there was, for all intents and purposes, a dead short. And that must have provoked a mighty spark at the AC connector, which is why we see this blackish goo, which actually is nothing more than a little bit of the rubber that melted. So, yeah, as you can see, this time it was the capacitor that shorted out, but what could short out next time? So, and as you can see, there is absolutely no fuse fitted into this circuit. So, which again makes me tell you that whenever you find an old appliance like this, which works on AC power, and you see there is no fuse in it, then please take the effort to build in a fuse, so that at least you'll sleep easy knowing that it can never catch fire, and it'll never ruin the electrical circuit in the house. Okay, I'll just end by noting two peculiarities of this radio. The chassis itself seems to be pure copper, and I mean by that actually copper, thick copper, and not copper plated steel, which is actually rather nice for me, because it means I will be able to clean it up, and I won't have to deal with rust, which is great. Another thing, a last thing I'll show you before I get on with changing a few resistors and caps in this chassis, is this part. It's rather small, so I'll use something to point at it. Let's see if I can focus. Yes. So this part, where my screwdriver is pointing to, I found rather peculiar. And I started looking on the schematic, and this tiny little cylinder here turns out to be a capacitor of 3.9 picofarads, which is really a peculiar kind of component. It's located between the two IF cans, and the V2 tube. I suspect the V2 tube is, in other words, the IF tube or IF amplifier. So this tiny little cylinder here is in effect a 3.9 picofarad capacitor, which on the schematic is marked as not as picofarad, but if you look closely at the schematic, is marked as 3.9 microfarad. So 3.9 picos. Just one more tip. If sometimes you read the value of a capacitor and the only thing you see on a capacitor is a number, for example 473, then you should read it as 47. In that instance, a 473 cap is nothing but a 47 nanofarad cap. And how do I know that? Well, the first two digits denote the value 47. The next number, which is a 3, says that you have to add 3 zeros. So 4, 7 and 3 zeros is 47,000 picofarads. Yeah, the value is always noted as picofarads. So 47,000 picofarads, if you divide that by 1000, it gives you 47 nanofarads. And that's how you calculate the value of a capacitor whenever you see only a number. Just take the first two digits and add as many zeros as the last digit is large. So if you have a 3, add 3 zeros. If you have a 4, add 4 zeros, etc. And that will give you the value in picofarads. Alright, so then the very, very last detail I want to show is this capacitor. It turns out this large tear-shaped part has 3 pins, and in effect inside this round-shaped part there are 2 capacitors, and if you look closely down at the bottom there's marked 2x 10k, so 2 times 10k, or in other words 2 times 10,000 picofarads, or if you divide by 1000 it's 2 times 10 nanofarad. In other words, this 3-legged thing here houses 2 capacitors with 1 common lead and 1 lead for each of the capacitors. So it didn't measure too well though. It measured on the one side 13 nanofarads and on the other 15 nanofarads. So most probably I'll end up by replacing this odd looking part too. Okay, so far so good. So I gave you an overlook of what I'm going to do. I'm going to change a couple of resistors here, and this capacitor I already changed this one, and this capacitor, and this one, and this diode. I'll change all these parts rated for either 400 volts or a quarter of a watt. And when I'm done with changing those parts, then I might tack in a few electrolytics temporarily so that we can test the radio. because I'm just as anxious as you are to hear it work. So that will be the next. The deeper I dig into this radio, so to speak, the more ingenious and strange things I seem to find in it. Yesterday, I showed you a few things on this radio that were, in my opinion, either interesting or strange. Like this strange little capacitor which you see here, at which I'm pointing. And also this weird looking and rather complicated switch arrangement, which would allow a user to switch the radio either between battery operation and mains power. Now, while I was replacing some of the capacitors, I think you remember that I told you that there is a double capacitor, something like this, which I replaced by two standard ones, which you see over there, the two little green ones. I didn't take the pains of replicating this yet, because I have no idea how I would make it. Perhaps with a little bit of either putty or maybe even clay might do the trick. I don't know. I have to try. Maybe I'll do it, maybe I won't. In any case, I might give it a shot, just for the sake of authenticity. Now, another part that I removed, and I'm sure the more observant of you will notice immediately which one I'm talking about, was the selenium rectifier. Well, here it is. This is the selenium rectifier, which I unmounted and replaced by a diode setup. Now, the schematic says that the diode, which you see here, at which I'm pointing, if you look closely, and now I really have to look at it with a magnifying glass, because it's really hard to see. But in fact, if you look very closely at the schematic, you'll see there is a tiny little plus symbol drawn at the cathode and a minus symbol drawn at the anode. So, strangely enough, they depicted what is actually the cathode of the diode as the positive side of the diode and not the negative one, which can be reasonably confusing. So the only way I could find out that they really meant that this is the cathode is because I noticed the plus of the electrolytic symbol here. There's a tiny little plus symbol drawn on top. and it's connected to this line. So in fact, I immediately knew that the diode orientation is fine, yet the symbols of polarity are not, or rather they are probably the old-fashioned way of depicting it. So that is rather strange and confusing. Also, just to see what type and what was wrong with this rectifier, the selenium rectifier. I don't know if you can see it, but the top corner of the rectifier is a deep dark brown. And if I look closely at it with magnifying glasses or anything, I think it looks like a little bit like burnt metal, you could say. So yeah, I think this selenium rectifier effectively burned through. Now, if you look at the face of the rectifier, you'll notice here, where I'm pointing at with my finger, there is a tiny little plus symbol. So effectively, this pin is the cathode, whereas the other pin is probably the anode. We'll check in a moment, but like I said, it's broken, so it won't give much. The brand of the rectifier is Federal, and it's rated for 55 milliamps, which is not that much, considering that a tiny little diode, like you see here, is rated for 1 amp, whereas this chunky diode, you could say, or rectifier, is rated only for 55 milliamps. So that just illustrates the evolution in technology from the 50s until now. Anyway, I tested continuity with my multimeter, and by the way, yes, it is a new multimeter because well, I blew up the other one, and well, there you are. I just bought a new one. I just hope this one will last a little bit longer. Okay, so let's see. To have a point of comparison or a point of reference, let's check continuity on this modern diode. As you can see, it reacts perfectly. If I reverse polarity, so I put the polarity like it is on the schematic, and I measure, I get nothing, obviously. So, in effect, the plus and minus symbols on the schematic are really confusing. So don't pay them too much attention. You know, don't trust too much the symbolics on the schematic, because it can confuse you and then you start to make mistakes. So actually the depiction of the diode itself is correct, but the polarities are not. So if you try to measure continuity of the diode, so I put the measuring contacts as they should be, so plus to anode, minus to cathode. There you go. Well, you see, I get absolutely nothing. Yeah. There's absolutely no conductance, no nothing. But if I, instead of measuring conductance, I measure resistance, that is what you get. If I measure across the diode in the correct direction of electrical flow, it gives a resistance of 3.2 mega ohms, which is way too high, obviously. Which means that this selenium rectifier, although perhaps not burned through completely, was certainly on the way of being burned, well, pretty nearly to a crisp. And probably at a certain stage the radio started to play less and less loudly, and it probably also started to detune more frequently and all that. So the radio must have degraded slowly. Well, that's one possibility. Or, like I said the last time, this failure happened immediately and catastrophically, because you remember one of the electrolytics, the 60 microfarad, probably burned through and made a short circuit from the rectifier circuit to ground, and thereby blowing up, or at least severely burning, the selenium rectifier. So yeah, there you go. I replaced those. Aside from replacing the rectifier and a few capacitors, I haven't replaced yet these two resistors. This is a 10 mega ohm resistor, or at least it's supposed to be a 10 mega ohm resistor, this one. And this one, the other one, is supposed to be a 1 mega ohm, this one. Now when I measure them, let's measure the 10 mega ohms. When I measure the 10 mega ohm, I get this. Give it a moment. So there you go. It gives a value of around 13.1 mega ohms. So which is 3 mega ohms, or even a bit more, over its intended value, which is 30%, which is way too much. If you have, let's say, a 10% tolerance, then 30% is way too much. So I'll have to replace this 10 mega ohms resistor. And then I measured this one, and that measured almost 1.3 mega ohms. This is also 30% of difference from the value it should be. So these two resistors have to be replaced by new ones, unfortunately perhaps, but that's it. Oh yeah, by the way, I decided against changing all the values, all the parts in the radio, simply because, well, I'm sorry to say I have to save a little bit of money somewhere, and on the other hand, I want to keep it as authentic as possible. So I just decided that I would replace the parts that measure seriously off their announced value and leave the others in. Which means, of course, that certain parts might fail in the future. But, well, I want to move on. I want to go a little bit faster than when I did or when I work on my Ever-Ready. So, let's say it's a conscious choice I made. Okay, before I finish this update, I want to ask you something. And I would say, look closely at this corner, this area of the radio. Now, do you see anything special? I mean, take a good look. Yeah, I'll show you around the radio from every angle. Yeah, I'll show you from this angle. I mean, do you see anything special? Well, I can tell you, I've been working on this radio already for, let's say, roughly a week. And it was only about half an hour ago I suddenly noticed this little piece. This one. And as you can see, it's like a small brown colored plate. And there are several thin wires running to it or out of it. In fact, I counted them. There are 7 of them. And I thought, this is weird. Until, of course, I looked a little bit closer at the schematic. And I noticed something that I hadn't really noticed at first. If you look closely at the schematic, you'll see a bunch of capacitors which are surrounded by a dotted line all around here. And in fact, what this means is that it's a capacitor network. Yeah, and as you can see, there are 1, 2, 3, 4, 5 capacitors in it. A couple of 5,000 microfarad, so 5,000 picofarads. So that's 5 nanofarads. So there are 2 5 nanofarad capacitors, one 2 nanofarads, and 2 150 picofarad capacitors in that one little ugly brown plate-like part, which is here. Yeah. So, and in fact, it's attached to tube. If I'm not mistaken, it's attached to tube V3. Let me see. Yes, to tube V3. And V3, so this tube, this one, is a 1U5 tube. Yeah, a mini tube, 1U5. Okay, I started to measure the values by choosing the right wires that come out of this little network plate. But unfortunately, well, either the values are so small, just like this tiny capacitor, that my meter can't handle it, or, well, the capacitors inside of it are seriously out of or beyond their factory value, because a capacitor, for example, of 150 picofarad measured almost 150 nanofarad. So, and if you look at the schematic, you'll see that it's marked like 150 microfarad. Yeah. So it is effectively, it should be 150 picos, and one of them at least measures almost 150 nanofarad. So, which is roughly 1,000 times larger. So unfortunately, probably, I will have to replace this capacitor network too. And that will be a fiddly job, and I'm not relishing the idea of having to do it. But I suppose at the values it is now, the radio won't really work. Well, it might work, but not very well. So in the end, I will probably have to resort to changing this network. But whether I'll be able to make one which looks like it and which is as small as this one, I really don't know. We'll see. Oh, just one last thing. This little network is mounted upside down. As you can see, the wires come out of it from the top, and actually what looks like the top is really the bottom of it. And the pins are numbered from 1 to 7, starting from here. So 1, 2, 3, 4, 5, 6, and pin 7 is here, which is actually a nude pin. So there you go. I was really flabbergasted when I noticed this, and I really slapped myself in the face and saying, how could I have missed something so obvious? Well, I don't know, but there you are. I finally noticed it. So that's where I'm standing now. I had to order a few parts, especially these capacitors, because I really don't have 5 nanofarad capacitors or 2 nanofarads or 150 picos. So I had to order these parts, and I also ordered a few slim electrolytics to fill the cardboard tube in which they will be housed. So until I get the parts, I'll keep busy by cleaning the radio up and maybe test a few more parts, specifically the IF coils and all that. So stay tuned, and I'll get back to you with a new update very soon. Thank you for watching. Bye bye.